So there are two ways to do question 2, and then I'm going to show you the two separate methods. The first method is the easy method, the algebraic method. So once again, we start off with a timeline. The first payment is 1, second payment is 2, third payment is 3, and so on. It keeps on going. And if you want to find the present value, this is essentially just the increasing annuity, but we just do it all the way to infinity, right? So all we have to do is just to substitute infinity into this expression over here. So this is the formula for the increasing annuity. So when n tends to infinity, this term is going to be 0 because as n tends to infinity, v to the power of n, this is going to tend to 0 much faster than how n tends to infinity. So this term is going to win. So overall, this whole thing is going to be equal to 0. Now a double dot n, that's just 1 minus v to the power of n divided by d. This is going to tend towards 0, so we get 1 over d. So in the end, we get 1 over I times d. And then if you compare it with the other expression that we have a infinity times a double dot infinity. So this expression is just 1 over I, this one's just 1 over d, so you get 1 over id. So you see that both of these are the same. So you see that this has to be true, so this is the expression for this payment over here. So this is the first method, the algebraic method. The second method, we can reason the result by using the concept of an annuity. And then we do something that's similar to what we did in the previous question. So instead of 1, 2, 3, 4, I'm going to break this up into separate perpetuities. So there's one perpetuity that starts payment at time 1. There's another perpetuity that stops payment at time 2. There's another one that starts at time 3. There's another one that starts at time 4. All these keep on going to infinity. So essentially all this, you can view this as perpetuity payments of 1 over I, because the present value of this payment here is 1 over I, and then the present value of this payment, if you're standing at time 1, is also 1 over I, and then the present value of this payment over here, starting at time 3, if you stand at time 2, the present value is also 1 over I. So you see it keeps on going. So receiving all this money is equivalent to receiving 1 over I at time 0, time 1, time 2, time 3, all the way to infinity. So essentially, you have a perpetuity due of 1 over i's. So you have a perpetuity due of 1 over i's. And this 1 over I is just an annuity, is just a perpetuity immediate, right? And there you have it, you have this expression over here. So this is the answer. So you find that this is the kind of verbal argument for this result, and this one is the algebraic argument. So you just choose the method that you prefer.